Hello friends, Gangadhar from the channel Maths Kanda. Now in this video I am going to deal with the question asked in January 2019, 11th January evening session from the concepts of progression. Actually it's a difficult question asked from progressions. It's a combination of binomial theorem along with the concepts of geometric progression. The question is given like this. Alpha times t100 is equals to 101 into s0, 101 c2 s1 plus and so on 101 c101 s100. And what is s0, s1, s100 and what is t100? For that they mentioned that sn has 1 plus q plus and so on plus q power n, whereas tn has 1 plus q plus 1 by 2 plus and so on plus q plus 1 by 2 power n. See, if you observe, Sn is sum of n terms of the geometric progression. So if you apply sum of n terms of the geometric progression, A into, what is the rule for the sum of n terms of the geometric progression? A into r power n minus 1 by r minus 1. Okay, see, A into r power the number of terms like. Okay, now coming to here, first term A is 1, whereas r, the common ratio, is q, and the number of terms are, this is q power 1 and this is q power 0, the number of terms are n plus 1, so q power n plus 1 minus 1 by r minus 1 is q minus 1. In the same manner, if you apply Sn of geometric progression for Tn, here also we have n plus 1 terms, along with the common ratio q plus 1 by 2, with the first term 1, so Tn is equals to 1 into q plus 1 by 2 power n plus 1 minus 1 by q plus 1 by 2 minus 1. So I have to replace S0, S1, S100 with this rule. Okay, and at the end I need to compare the result with this Tn by replacing the 100, T100 to get the value of alpha. So what I have to do? See, what I have to do, if you observe, the task is very easy. What is S0? Okay, if you replace 0 in the place of n, S0 will be q minus 1 by q minus 1. So that is equals to 101 c1 into q minus 1 by q minus 1 plus 101 c2 s1. By replacing n with 1, you will get it as q square minus 1 by q minus 1 plus and so on. In the same manner we will get the remaining terms 101 c101, that is q. By replacing n with 100, we have that q power 101 minus 1 by q minus 1. See, if you observe, q minus 1 is a common thing for each and everything. So just you common out that one. 1 by q minus 1 times, okay, 101 c1q, 101 c2 q square, 101 c 101 q power 101. So the terms involving q I need to figure out. 101 c1 q, okay, plus 101 c2 q square plus and so on plus 101 c 101 q power 101. These are the terms involved with q, minus mention the terms which are not involved with q. So 101 c1 into 1, and it is 101 c1 plus 101 c2 into 1, and it is 101 c2 and so on plus 101 c 101. Okay, now we need to utilize the concepts of the binomial theorem. See, 101 c1q, we don't have 101 c0, right? 101 c0 is actually 1. So if we have 101 c0, 101 c0 plus 101 c1 into q plus 101 c2 into q square plus up to 101 c 101 q power 101. It is directly of the format like 1 plus x to the power n form only. Okay, if you have 101 c0 here, and here also 101 c0 undunte, which is nothing but sum of n binomial coefficients whose result is nothing but 2 power 1. Okay, I think you are very familiar with the sum of binomial coefficients like nc0 plus nc1, nc2, nc3 up to ncn. If you add, the summation is 2 power n. So by using the expansion for 1 plus x to the power n as well as 2 power n, I am rewriting it like this. Okay, so I am again moving in the upward step. I am doing this one. So what I will have, that is equals to 1 by q minus 1 into this total summation is nothing but 1 plus q to the power 101 minus 1. Actually 101 C0 to be here. So add 101 C0 and subtract 101 C0. By adding 101 C0, that is this expression minus 1. Minus of this summation is again nothing but 2 power 101 minus 1. Now we need to simplify. Here I have minus 1. Minus of minus is plus 1. This minus 1 and along with the plus 1 will get cancelled. So what I have in the next step? So I have that 1 plus q to the power 101 minus 2 power 101. What I need to simplify it? I am going to simplify it to make it as P100. What is P100 actually? Replace 100 here. Q plus 1 by 2 power 101. Q plus 1 by 2 minus 1. So to make it like that, what I am going to do is, see this minus 1 and plus 1 get cancelled. So by cancelling minus 1, minus of minus plus 1, what I have? 1 plus q to the power 101 minus 2 power 101. You just common out 2 power 101 to the outside. So I have the 2 power 101 divided by q minus 1 along with 1 plus q by 2 to the power 101 minus 1. Right? Now, see, I have 2 power 101 here. So I am writing it like this 2 power 100 by q minus 1 by 2. And this q minus 1 by 2 is nothing but q plus 1 by 2 minus 1. So rewrite this q minus 1 by 2 as q plus 1 by 2 minus 1. Now this 1 plus q by 2 power 101 minus 1 by q plus 1 by 2 minus 1. This total thing is nothing but t power 100. So this is equals to 2 power 100 into t100. So by comparing this with alpha into t power 100, your value of alpha is 2 power 100. So the problem is a little bit of calculative skill along with dare to solve the problem. Okay, somewhat a difficult question with the combination of binomial theorem along with the concept of progression. Thank you.